last session, and it's gonna be super fast because we have one of the things we needed to go through during the course of the three previous sessions that we have had. Right. So today it will be, just about deploying the contract we built on Sunday, and also basically building upon that class last Sunday, right? So just showing you some what's it called? Some career paths in Web3, especially Web3 security, right? What's it called? Which I am. I am a Web3 security researcher, right? So yeah, let's just dive in, right? So let me share my screen, right? Okay, share screen. Yeah, share entire screen. Okay, let me share my screen. All right, great. Okay, guys, please can you confirm if you can see my screen? Can you see my screen now? Anybody? I mean, just react if you know the thing. I can know if you're seeing my screen. Okay, great, thank you. So, where did we stop? So, okay, great. So, I mean, in the last class, yeah, we wrote our file sets code, right? Let me move this now. Sorry. Okay. Oh. Okay. So guys, in our last class, yeah, or in our last session rather, we wrote our file sets smart contracts, right? So basically, for those that were not here, let me just do a quick recap here. So a file set is basically a smart contract that you can request certain tokens, right? And then it will give you that token as far as it has the balance in its own balance. So basically, it's like going to request for tokens. Most times it used to be for test tokens, right? So because we are building and we are trying to deploy our contracts, we would need to have test token in our contract that we can be able to give people that request for it. So basically, that's literally the concept of file sets. So it gives you test token, right, that you specify. So in this contract here, we add some functions. We wrote some functions, which is one of them is to deposit, where users or anyone on the blockchain can deposit Ether, that's Ethereum. But in this case, it's going to be Sepolia Ethereum because we'll be deploying this on Sepolia Ethereum network. So this function, let me highlight it. So this function enable users to deposit any amount of Ether that is greater than 0 into these smart contracts, right? So why is this? Because our smart contract gives out Ether, would need to find a way to reimburse the Ether it gives out so that it will not run out of Ether eventually. So that is why this deposit function is. So this deposit function is like a function that users can call to give the smart contract Ether that it can eventually give out. So now this is another function which is request fund. So this function is basically the core concept of the file sets where users or anybody on the blockchain can on the blockchain that is deployed and request what's it called? And request Ether from this smart contract. So we have a limit to how much can be requested, and that's what we set here. We said 0.001 Ether is the amount that can be requested. So anytime this function is triggered, right, it's expected that it sends 0.001 Ether to the balance or to the user that is requesting it, right? In this case, the user is going to be the wallet address that is requesting this, right? So we also, have another function which is a set withdrawal amount, right? You know, the withdrawal amount has been set here to 0.01 Ether by default, right? So here in this place, we can adjust the withdrawal amount, right? And you see that it has a modifier in front, which means only owner. So basically, what this means is that only the owner of this contract. So the owner of the contract is the person that deploys the contract. So because I'm going to be deploying this contract with a wallet I control, so the owner of that wallet is going to be me, basically, me, right? Basically, it's going to be me. You get because I'm using my wallet to one of the wallet I control to deploy this, right? So it means that for this function that has this set, that has this only owner modifier, right? So what does it do? It literally just check if the person calling this particular function is the owner, right? And this is where we declare the modifier here. You can see, so it literally just check if the message of sender. So message of sender is a global term on the blockchain that is used to know the person that is making a function call, basically. So it checks. So in the case where I send a request to this smart contract, the message you're sender is going to be my wallet address. So if Friday, for instance, uses wallet to interact with this contract, Friday is going to be, message the sender. You get so basically it's a global term that is used to check or used to, denote the person that is making the wallet that is making a request. So basically what this does is it checks if the message sender is equals to the owner. If not, it shows an error, right? Said only, it shows an error that says only the owner can perform this action. So any of the functions that is, you know, um, that declares this only modifier, right? This only owner modifier, um, it's going to be guided by that check mark, which what's it called? What it does is it's literally just check if the person making the function call is the owner. So you can see that we declared it here as well in this set cooldown time. So basically, no user can call this except from the owner of this smart contract, and the owner is the person that deploys the contract, right? And lastly, we have what's it called? Okay, let me explain the cooldown time. The cooldown time is literally meant for a time frame that another user or a user can request for the file set. So in this smart contract, we had written the code in such a way that the cooldown time is set to okay, so the cooldown time is set to 1 hour. It means that if I call this function, which I'm going to do like very soon, if I call this function after it has been deployed, if I call this function, the first time I call it's going to go through. You get so I'm going to receive the ether. If I call it again, and the time frame is within an hour that I called it last, right? It's going to throw an error and say that wait before requesting. So basically, saying I should wait for 1 hour before I request it, right? So what's it called? And this last function is to receive ether, right? So basically, any smart contract or every smart contract that declares this receive function means that it is what allows the smart contract to accept tokens from users you get. So because we are dealing with tokens here, we need to have this function. So yeah, so that's a recap. So let's just continue from where we stopped last week. So now after we wrote the code, right, let's try and compile it. So to compile, we're going to come to this place, this run sign here, or we can come here, but let's just do it from here to be, to be to be much more faster. So we'll click on this play button here. When we click on it, it's going to compile, right? So compilation means that it is converting our code, right, to a code that the computer will understand. So this code now is actually readable because we're the one that writes it, you understand? So it converts this code to a byte code because EVMs, virtual machines rather, understands bytecode. So anytime you write code like this, it does not understand it. Rather, the virtual machine has to convert this our code that we have written in Solidity into bytecodes that the computer will understand and execute for us. So that's the process of compilation, right? So now when we see, if we check here, which is solidity complier, we see that we have a green mark here. It means that our compilation is successful. You get, it means that, okay, what it means is that, okay, oh, guys, our contract, the code has been successfully converted to bytecode, and now the computer can, understand. I mean, the virtual machine can understand and execute our code well. So it literally means that our code does not have, noticeable error, or what do they call it? They call it compilation error, basically. So we have so that's like the process of compiling your code, especially on what's it called, on Remix. So you come up here, you click on compile, or you can just click on Control S, right? And it's going to compile. So, or you come here and you click on compile file set or so, right? So because we have set or so automatically here, because it's one of the contracts that is, or it's the only contract that we have written in this remix here. So it's the only contract here. So by default, it's going to be the one that we should compile rather. So when I click on it, it's going to compile, and you can see again that it's successful, right? So now that it's successful, so the next thing is the most important thing. So we want to deploy our code, right? So deploying as this code is now, like nobody can interact with it. Nobody knows what this code is, right? It's not available on the blockchain. So, sorry guys. So the what's it called? The only people that know about this code is just me and everybody else in this code, because it's not available on the blockchain yet. So deploying the code is a way of, us having to take it to the blockchain that is easily accessible to everyone. So the process is you're going to come here to this fourth icon. So this is the first icon, second icon. This place is where our file would be. This is where we can search for the files. This is where we compile. This is where we deploy our code, right? This is where we debug, and this is where we do our Git, what's it called, our Git operations. But then we're only concerned with this 1, 2, 3. So here is where we put our code here. So when we come here and check the contract, we see that we have offset.contract under this contract folder, which is this code basically, right? So we have already compiled it, right? And then let's try and deploy now. So to deploy, I'm going to use two ways to deploy. So I'm going to deploy on the virtual machine that Remix actually provides by default, right? So this is going to be confined inside Remix, so it's not going to be available on like Sepolia, Ethereum, or anything yet. So I'm going to deploy this on two network, which is the Remix virtual machine and the Cancun network by default here. And I'm also going to deploy this on Sepolia Ethereum, which all of us can now have access to. So let's just quickly do that real quick. So to deploy anything here, so we have to provide the environment, right? And we have to provide the account. So the account is literally the wallet address, right? So when we come here, we're going to see by default, we have Remix virtual machine. So we'll click on it, and then it's going to generate a wallet automatically for us, because this is literally just like a playground, like a test this thing. So because it's not going to deploy on something that we can have access to. If it I mean, if we're deploying it on something that we have access to, like Sepolia Ethereum, I would use my MetaMask to like connect it. I think there's a chat. Let me see. So okay. Anyway, the last class and the last session and this particular one is, where we just had to write some code to like deploy, what's it called? To just show how to build smart contracts. This is for, the comment that Marashi just dropped, right? So I mean, it's been chatty and interactive like the previous, two sections before now. So don't worry, just stick around. It's gonna be fun. So guys, let's try and deploy our contract, right? So to deploy our contract, we have provided the environment, which is the Remix virtual machine environment, and it automatically generated a wallet for us to deploy. So all we have to do is we're just going to come here, and by default, I've already seen that Sepolia faucet is already the contract that we want to deploy. So if we have multiple contracts, if we want to select the one that we want to deploy, we'll just come here, and then we will see a drop down of all the contract that we have on Remix and would click on the one that I want to deploy. But because, Sepolia faucet is only the code that we have here, so by default, automatically, it's just the only this thing, only contract that we're going to deploy. So after we've selected, we have selected our contracts, provided the environment, and intergenerated the wallet for us. So all we have to do is just click on deploy, right? So when we deploy, what's it called? We'll scroll down and we'll see that we have a wallet. We have a contract after our name, which is Sepolia Faucet, and we have a contract address that is generated for us. So when we click on it, we should see this. So basically, this is literally just saying, okay, our contract has been successfully deployed, and now it is available on the Remix virtual machine, blockchain network, basically. And then this is the name of the contract address. If you notice, the name is the same thing here because we have already declared the name here, Sepolia Faucet. So we can see Sepolia Faucet at OX7, blah, 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 blah. Then it ends with 8C. So when we copy this address, we should see that, let me show you my, this thing. So this is my, what's it called? This is my clipboard here. So you can see that this is the address in the full that was generated for us. So basically, you know that we have two types of, at least as of now, we have two types of address, which is the externally owned account, which is like my MetaMask and every other wallet that we have. And we also have smart contract address or contract address for short. So contract address is basically an address that belongs to a contract, right? So for any contract or for any smart contract that is deployed on the blockchain, it would have a contract address. Why for any wallet that we create on our wallet provider like MetaMask, we're going to have a wallet address for that. So basically, that's our pathway or our gateway to the blockchain, because we're going to access the blockchain with our wallets. Because we need to sign transactions and also maybe keep our tokens that we're going to store in our wallet or something. So so far, any questions so far? Or should I say, are we understanding? Okay, just to confirm, can people see, can you okay, I can see it comes up. All right, thanks. So it means I
Yeah.
am audible and we are following up. So thank you guys. So yeah, so let's try and interact with our what's it called? Our our smart contracts. So Remix sort of provide a way, an interface that we can use to what's it called, interact with our smart contracts, right? And we could see that if we check here in this terminal, when we check here, we'll see a green mark, right? This is literally, let me expand this. So what this is saying is that is okay, let me put this up. So it's saying that our call to deploy this function, which is sepolia.fileset, right? Our call to deploy the function was successful, right? So, and it calls our constructor method, which is here. Our constructor method actually sets the address of the deployer as the owner. And then this owner cannot be used to perform this only owner modifier here. So by default, any code in the constructor is what is called when the contract is deployed. So that's what happened here. So during deployment, this smart contracts, the construction function was called, right? Which set the owner of this smart contract to my wallet, basically, because I'm the one making the request, like the message sender. Why I said my wallet, like it's literally the wallet that this wallet here, OX5B3, blah, blah, blah. You can see that is a wallet that Remix provided for me by default, and I control it at the moment. So when this is done, it creates a block hash, right? So when I deploy this on Sepolia very soon, we will be able to access all this on the blockchain and see how it is on the Sepolia blockchain. So anywhere we see the green tab, it means that we have done something rightly and something that's executed successfully, right? So now that we have our what's it called, our function or our smart contract on the Remix blockchain, what we have to do is to test it, right? So we have this deposit function, we have the request fund function as well. We have the set withdrawal function, which is here. And then we have the set cooldown time, which is this cooldown time here. And then, I mean, set cooldown time here. We also have the cooldown time, the owner, and the withdrawer. So basically, these are functions here, like the deposit request, set cooldown time, set withdrawal. So by default, in our last class, we went through variables, right? So by default, on Solidity, when we deploy our smart contract on Solidity. So I remember that variables are always declared before functions, right? So we can say that these are variables: owner, withdrawal, amount, and cooldown time. So by default, we don't need to write a get, maybe a function to like get the owner, which will return the owner address, or the function to like get the withdrawal amount, because by default, Solidity provides a get, variable. What's it called? It provides a get variable for us, basically. Like, what do I mean by this? So since we declared three variables here, we can see that here now we can make a call to the owner, and it's going to it's going to return the owner's address. Yeah, if we click on, okay, let me just do it in real time. So now, if I click on this withdrawal amount now, I should see 0.001. Let me click on it. So withdrawal amount, then we can see, okay. So while we're saying this, right? So this is how to represent 0.001 ether in way. So it should have 16 zeros in front. If you remember that, 1 ether is equals to um 1 times 10 to the power 18 way, which means that it's going to be 1, then to have 18 zeros in front, right? So because we're setting this to 0.01 ether, so is literally just taking out, if we're going to, is taking out like two zeros, right? Because it's taking out two zeros from, 1 ether basically, or one way representation of a ether. And since 1 ether is like 1 times 10 to the power 18, right? If we're saying 0.01 ether, that means 0.01 ether is going to be 10 raised to the power 16 way, basically. So what's it called? So this is returning the what's it called? The visual amount in way instead of ether, right? Which by default it does. So this is how to say 0.01 ether in way, basically, right? So when we click on visual amount, we see that it's showing 0.01 ether, but it's represented as way, which will be 1 times 10 to the power 16. So basically, that's what we have here, right? So when we click on owner, so if I make, because I use this wallet, this address to deploy this contract. So you should see that if I click on that owner now, I expect that it's going to return an address that starts with this address, basically, that starts with 0x5b and ends with 4c. So let's try it out. When we click on owner, so yeah, it returns the full address. So 0x53 and it ends with 64, which is literally the address that is here, right? So and what's that last one again, Seth? Cooldown time. So cooldown time is set to 1 hour. So let's click on it and see what we're going to see. So this represents it in seconds. So 1 hour has three three 3,600 seconds. I mean, 60 seconds make 1 minute. So when times 60 times 60 minutes, that will give us 3,600. So it is representing it in units, right? So this the cooldown time, which okay, should I say, yeah, now it's representing it in its SI units basically. So Ethereum is being represented as way, our hour is represented as seconds. So basically, this is 1 hour here because this is 3,600 seconds. Yeah, so our cooldown time is 1 hour. That's what this is trying to tell us, right? Which originally it should work. So basically, because we have declared that visual amount is equals to 0.01 ether, and then it's represented as way here, right? So this is how to represent 0.01 ether as way, and then the cooldown time is set to seconds, which is how we represent what's it called? I represent 1 hour in seconds, right? So and then our owner is just literally returning the deployer's address, which is the address that Remus has given us here, and the same thing. So so let's continue, right, and interact with the smart contracts through its functions. So now when you click on deposit, what's supposed to happen, right? It's supposed to check if what's it called? If the value we're passing, so the value we're passing is literally like the amount that I want to send to this deposit, to this smart contract, right? So it's checking if the amount we're going to pass is going to be greater than zero. If it is, it's going to, send that amount that we have passed from our wallet address to the smart contract, right? If it is not, then it returns an error that it must be greater than I mean, you must send ETA basically, right? So it's just telling us that okay, the amount you pass is zero. We're not sending any ETA, so why are you calling it deposit function? So let's try it out and see if it's going to do like that. So now, because this is just like the RAM is provided for us, right? And I'm controlling it at the moment, right? When I was don't worry, when I very soon I'm going to deploy on the Sepolia Ethereum. So we'll do all these things, we're going to do it on like MetaMask rather than doing it here. So let's click on, okay, so now this is where to pass the value, right? So we have set the value to zero, right? So it means that message.value is going to be equal to zero here. So originally we expect that when we call this function call, I mean, this deposit function is not going to go through. It should return this error instead, right? So let's see, let's just try and see if we have done something right or wrong. So when we click on deposit, we see that rather than it showing green, like the other ones that we have clicked on, it showed red here on the terminal. And when we read this message is sending to us, we see that it's reverted, right? So revert means that something happened during execution and so the execution flow was not successful, right? It means that an error was thrown or an error occurred. We could see a error occurred. And what error is that? It reverts. So when we read this message, right, we can use this to debug. So what happened though? Okay, it said that, it threw an error and that error says that must send it to deposit. And when we look at our code here, it's just literally telling us it's just, showing us what it actually needed to do when message as value is not greater than zero, you get. So, okay, so now it's very clear that, okay, this, to make this function call, it expects that the message as value should be greater than zero. So let's try and add one Ethereum, right? Because we're representing as ETA here, we're sending ETA, right? So one ETA, which means that's greater than zero, because one is greater than zero. But let's call that function again. By the way, if we look at our balance, so by default, when you create your own wallet, like we did in session one of this thing 4 weeks ago, you saw that we had the balance, right? So the same way applies to smart contracts. So when we deploy our smart contract, it's going to have its own balance too. You get. So by default, yeah, now we can see that this file set has zero balance, which means that if we call this request from funds now, but they're supposed to send 0.01 ether, this should revert because it does not have enough balance, right? So let's just try that and see. So we said that it's what's it called? It actually did not go through because there is no, you can see that what's the saying here is the distance, the amount is trying to send, or the 0.01 ether we're trying to send to this address that call this function, that 0.01 ether, I no get you get, so because the balance is zero. So okay, so this meeting will soon end in 10 minutes time. So when it ends, please just rejoin with the same link, right? So that should be the last session, right? So yeah, so let's try and deposit what's it called, ether to this smart contract so that we can have what's it called, um ether in this smart contract. So we'll click on the message as value, right? It's going to be one that we set to one already, right? And then we'll click on deposit. So we'll click on deposit so that it has gone through, right? So let's drop down and see what happened. Okay. So basically, what happened here? This is like the most important thing here. So this is like the argument, or this is like the message that was passed, right? So this returns like the address of the person that called it, and you can see that this address is something as our address. Let me highlight it so that we can see. So you see that okay, this sender, you can even see it here, sender and amount, right? You can see that the sender, the address in the center correlates with the address that is here. It starts with OX and it ends with C4, you can see. So it's trying to just say that, okay, this function was called by this person. And what was passed? 1 ether. So it's representing this in where here. And you know that 1 ether is 0.01 ether. So it's representing this in where here. And you know that 1 ether is 0.01 ether. 1 times 10 raised to the power 18 where, which means that it's going to have one that would have, 18 zeros in front of it, right? So that is what's represented here. So now with this now, it's increased our what's it called smart contract balance by 1 because we passed 1 right into this deposit function. So now we can see that our balance that was 0 here before is now 1. So let's try and pass another, let's try and pass 0 again. So we expect it to revert because it expects that the message value should be greater than 0, right? So that's why it's reverting again. So let's try and increment. Let's just pass 5 ether because why I'm doing this is if we check the balance of this address that I'm controlling that Rem is provided, it has this is the dummy balance, so it has like 98 ether. So if I pass, let me try and pass 99, which is greater than the balance here. It should revert because I did not have. You can see that it's reversed because I did not have up to that. So yeah, I only have 98 ether left. So let me try and send 20 ether so we can have more than enough Ethereum to cover our transactions or to cover our request funds, right? So let's did I click on deploy? No, let's deposit with 20 ether. Right. So it's pending. Uh okay. So let's see what happened. So I think, well, okay. What I did that time was to click on deploy. So it's deployed another contract for us, right? So let me see. Deposits. It should go through. But it's pending actually. So let's wait a while. Okay. So now what we're going to do is we'll just redeploy our smart contract, right? Since it's taking time. So because I clicked on deploy the other time mistakenly. So let's just redeploy our contract and then retest. You get so compile, we compile it and then we deploy, right? We come here and click on deploy. So it's creating. Okay, I'm coming, just hold on. But let's try and change the virtual machine to let me see to this. Okay, so okay, so I mean, all right. So it's making what's it called? Okay, so let's try and deploy now. It's just slow, right? All right, nice. So it has successfully deployed, right? So when we see that, if you could remember, because smart contracts basically are immutable, like anything, because of how the blockchain works, right? Anything on the blockchain cannot be rolled back or cannot be, changed, right? So if that smart contract we're interacting with before now, right? Because we're having some problems, we had to deploy another smart contract, right? So, um, you know, so now when we deploy another smart contract, it's returns another different address, right? So this smart contract, even if they have this, even if it's still the same file set.so that we deployed, right? It had to generate another contract address for us. So it deployed another new smart contract instead of bringing back that one. So it deployed a new one. You get so what's it called? So let's say even if we want to, let's say we kind of make a change to this code and say the ether, the minimum withdrawal amount should be 0.02 ether or 0.03. If I'm going to deploy this or deploy this, I have to compile it again and then redeploy as another smart contract, right? So you cannot change the one that has been deployed before, right? So that's why everything on the blockchain, I mean, when we say since on the blockchain are immutable, it means that it cannot be changed. So this is like a practical example, right? So now let's just continue from where we stopped, right? So because, this is a new contract that we just deployed has a balance of 0, but let's try and fund it with more balance that like we have done in that other one. So let me pass to and call deposits. So it's successful, and now we have 2 Ethereum. So let's just have more than enough. So let me pass. You remember that if I pass 0, it's going to revert. Let me do it again here. Deposits. And see that it reverts here, and it says that this thing there must be ether, like it's not greater than 0 basically. So let's just try and pass 20 so that we have more than enough ether, and then deploy and deposit rather. So now we can see that we have 22 Ethereum in this contract, right? So now let's call request fund, which should give us 0.01 ether. And when we call this request fund, what should it do? Let's check the code. So it checks for if the balance of this smart contract is greater than or equal to the withdrawal amount, which is 0.001, right? So, and it checks the last time that we have withdrawn so that it can check if it can compare with the cooldown time so that we'll not be able to withdraw 2 times in the space of 1 hour. So let's click on request fund. Yeah, we should increment. You can see that here now, our balance is 77.9. So when we click on this request fund, like I am literally requesting the fund from the smart contract to give me 0.01 ether. Before we have been depositing into the smart contract. So let's click on request fund and see if it's going to go through. So it's pending. Okay, yeah, so nice, successful, right? So what happened? We see that our balance of 22 ether in the smart contract before has actually decreased by 0.001. It means that our call to request fund was successful. So when I check my balance here now, it was 79 point something before, now it's already 78. I mean, it was 77.9. Now it's 78. So it's increased by 0.01. You get, so it means that our contract is working as expected. So now, because I've already requested it before, I mean, I know that how this request fund is that it's when you call it with an address, you need to wait for like 1 more hour to call it again, right? So if it's when I call it now and I call it again, right? I should see this error. It should not go through. It should not increment my balance by 0.01. And instead, I should see this error ideally and say wait before requesting again because I'm requesting, within the space of 1 hour. Let me quickly try that request fund. So you see that it reverts, and as it reverted, if we look at the error message that it brings out, it says we should wait before requesting again. So it means that our smart contract is actually working as it should due to what we have written in this code, right? So this meeting would end in less than 1 minute. So when it ends, just rejoin back with the link again. I'll restart the meeting. And that session will be the last session, right? So yeah.